My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, A Jurassic Record Encodes an Analogous Dansgaard-Oeschger Climate Periodicity. Earth's past climate exhibits a prominent millennial-scale quasi-cyclic variability, which is a period of about 1500 years. Such cyclicity, known as the Dansgaard-Oeschger or DO glacial variations, is characterized by brief, decadal scale shifts from stadial cold to interstadial warm climates, called the DO events, followed by slow transitions back to stadials within centuries to millennia.
Single DO events have been simulated to result from atmospheric temperature warming of up to 15 degrees Celsius, within a few decades, pointing to abrupt and severe changes in Earth's past climate. The record of DO-equivalent climate variability in Mesozoic strata can provide constraints on understanding these events.
That is so intriguing, Boson. This study highlights a prominent 1500-year cyclicity in a Jurassic, approximately 155 million years, ice-free sedimentary record from the Tethyan Basin. This Jurassic 1500-year cyclicity is encoded in high-resolution magnetic susceptibility proxy data, reflecting detrital variations, and expressed as marl limestone couplets. The researchers performed calcareous nanofossil and mineralogical analyses on 5 DO scale cycles.
What is interesting about this analysis is the following. Numerous studies argue for or against the cyclic nature of the quaternary DO glacial events. Deciphering the cyclic versus acyclic character of DO events provides a valuable information on their physical drivers. In general, studies for the cyclic behavior suggest an external driving force, while studies against suggest internal factors to the climate system. This study highlights the dominance of precession and its harmonics as characteristic of the equatorial and intertropical climate regions.
Great point, Boson. The researchers conclude that the analyzed paleoclimate record of the late Jurassic supports the global nature of DO-like events, and in particular that their potential primary cause is independent to ice sheet dynamics. This is an important observation.
That is wonderful, Higgs. This Jurassic record of DO-equivalent periodicity may be analogous to late Pleistocene East Asian monsoon archives, that also document DO-scale climate variability, due to the specific paleogeography of the subalpine basin and climate conditions in the late Jurassic. That was an interesting paper. Hope you liked it. Please follow the links to review the research in further details.